Thank you, Lauren. And thank you, Ken, for such a wonderful keynote. It's a great segue into our talk. With that, I'd like to invite up our panelists, Olivia Holzhaus, Gámez from Rhodium Scientific, Brad from VAST, and Lee Pagel from NASA. So, oh yeah, a little tight here. So, good morning once again, everybody. As we all know, the space station is an incredible platform used for innovation, allowing researchers to push the limits of research and technology development to benefit our planet and further humanity's footprint in space. As Ken alluded to earlier, it's the 23rd anniversary of human presence, but it's also about to be the 25th anniversary of the first module that launched to create the ISS. That comes up later this month. And since that time frame, thousands of investigations have launched to the ISS. Hundreds of astronauts have visited to live and work, and more than 500 peer-reviewed results have been published. But alas, all good things must come to an end, which is the purpose of today's conversation. At some point, whether it be in 2030 or a little beyond, we will move on from the International Space Station and segue to commercial LEO destinations. NASA's Commercial LEO Destination Program was initiated to replace the ISS by 2030. This faces significant challenges and uncertainties such as technical risks, regulatory hurdles, and market demand. In particular, this panel will focus on these three critical topics. We are joined here today by a mixture of NASA and private sector partners to outline these challenges and what we can do to overcome them. Hopefully, we'll have some time for questions afterwards, and we'll begin the panel. So with that, I'd like to have the panelists introduce themselves a little bit. So we'll start with Olivia. Why don't you go first?
Hello, good morning. I'm Olivia Gámez Holzhaus, founder and CEO of Rhodium Scientific. Founded the company in 2014, not as a space-based company, but we are a biotech company. And we are still a biotech company operating in the environment of space. We are partnered with the ISS National Laboratory and one of the 13 commercial services providers to the ISS. We specialize in biotech and pharma payloads and are the preferred partner for biological sciences of the DoD in space.
Great, thanks, Olivia. Hey, everybody, Brad Powell from VAST Space. Real quick show of hands, who's familiar with us already? Okay, good. So at VAST, we are currently underway developing the Haven 1 mission, and Ken mentioned sort of the collaborations for commercial space capabilities program, which we're a part of, and getting a lot of value out of that. So Haven 1 is scheduled to launch in the latter half of 2025 on a Falcon 9. We're scoping out that mission to have a life of 3 years. So we're going to have a single module station that'll be operating on its own for a period of time, and then a mated configuration with Dragon for when we have crew on board. And over that 3 years of mission life, we expect to be able to fly up to 4 crewed missions. So happy to talk more about the sort of scope of that program with y'all, and we're very much looking forward to developing a capability that should be compelling for future CLD program.
Good morning, I'm Lee Pagel. I work in the Commercial Space Division, working for Ken Bowersox. And I have had the opportunity to work on many of the really innovative commercial partnerships that we've had over the years, including the collaborations that we just awarded and the commercial LEO development platforms that was a couple of years ago, commercial crew. So that's where I work every day, and I'm happy to be here.
All right, well, let's jump right in with some tough questions, huh? All right. Olivia, let's start with you. From your point of view, what do you think are some of the key regulatory hurdles that we need to work on before the CLDs are ready to operate?
Yeah, good one. So I come from the payload perspective. I know there's a lot of ships in the room being built, but we are the cargo and we are the client. And so from the biotech and pharma perspective and position, there are regulatory hurdles that aren't even being discussed in, well, they now will be in rooms today. And when thinking about CLDs, such as, the transfer of compliance from FDA regulated products, if you're going to bring back anything that's touched by animals or consumers, currently right now, until there's something said otherwise, for space-based products, it does have to go through a series of good laboratory practices to make sure that that product is able to be consumed and used by a human or an animal. Other things to consider are ITAR and ethical implications. A product on Earth and a product in space might look very, very different, even though it's the same thing. And so thinking about strategies to define what is an ITAR compliant or non-compliant article once it's formed in space should be discussed, such as, well, we won't go there. That's another science topic. But thinking, right now I'm on, Rhodium Scientific is the spaceflight partner for DARPA in biomanufacturing. And one thing that was recently brought to my attention in the last year is DoD is, heavy in ethical considerations of genome editing and development of novel molecules and bacteria strains. So ELSI, the ethical and legal social implications of genome editing, is something that DoD is really interested in and really would like to comply with, especially in our space-based biomanufacturing programs for testing out processes. So those are just a few things that I think are not realized yet, but could be, and the CLD who pays close attention to those will win the business of the biotech and DoD market.
So Brad, as the owner and operator of a future CLD, what are some of the regulatory hurdles you're worried about?
Yeah, thanks, Robbie. So we're in an interesting position right now because for our first platform in Haven 1, we're operating in a context that is outside the scope of the sort of current CLD program as such, right? So the requirements we have are largely being driven by the goals we have for ourselves and also what we're hearing from our customers. But in light of that, from sort of the regulatory or quasi-regulatory perspective, we're taking good stock of all of the sort of years of learning, the decades of learning that the ISS has brought, thinking hard on questions of safety, mission assurance, and the like, looking at the standards that exist that we would expect to see in a potentially different form or fashion through the CLD program, whether it's Standard 3001 and the like, looking at the work of the ASTM and F47 committee, ISO standards to give full scope to a program that we believe is going to be successful and operate on a timeline that will sort of be flying well ahead of the targets that the CLD program has right now. But as I mentioned, it's an interesting environment because we are truly a commercial endeavor. We're wholly backed by our founder, Jed McCaleb, and that's enabling us to proceed with the development that we've already sort of undertaken sort of ambitiously and expeditiously to launch on that schedule that we have with SpaceX. So the regulatory environment for us is a bit unique, I'd characterize, because we're operating in the current state of sort of ongoing questions here in town on what will mission authorization look like, what will other forms of regulatory concern look like 3 years from now rather than today, right? And we're following all those conversations pretty closely and trying to be a meaningful contributor to that dialogue.
All right, thanks, Brad. So Lee, you've heard from a couple of industry folks here that are concerned about what challenges we face moving forward. From your perspective, what should the government be doing to help shape the regulation or certification process for these future platforms? How do you do that without stifling this market demand that we're trying to create?
Well, first, I need to say what all of you are expecting me to say, that NASA is not a regulatory agency, and that this is not our role. However, we are making an impact because we are developing safety standards that the future regulatory agencies will be taking a close look at, and hopefully will be modeling and accepting some of those in their process. I think where NASA can make a difference is in writing those safety standards in such a way that they can be accepted as industry standards, as regulatory standards. Right now, I think Ken mentioned this, but he kind of sold himself short. He is directly working with the FAA. We, as an agency, are directly working with the FAA to help them to consciously pass on our knowledge and understanding so that it informs their regulatory stance in the future. So we're partners with them and we participate in that process. I think also, though, if we can be innovative here and work on some alternative methodologies. And what I'm thinking of right now is our suborbital crew project, which is part of the Commercial Crew Program. And they are looking at safety standards and a new method of certifying, sorry, I said it again, certifying certifying these suborbital launchers for use by NASA employees. They're doing it differently. And so that'll be a new model, and when that is successful, we can show that to regulators as well and say, here's another way you could do this. I think even looking at the way ISS was built and honestly certified. I mean, it wasn't certified in the sense that it used the same process we used on a commercial crew. That it was way in the past before we had such a process developed. But there was a decision made on what was safe enough and what isn't. And that knowledge and expertise still exist in the agency, and we can rely on that to develop what could be future regulations and to inform the process.
Yeah, I think that's a great response, Lee. You know, we really need to help shape what the future looks like without stifling the process, you know. Brad, as we kind of move forward in this transition period and you guys are developing your spacecraft and, you know, you have grander plans after Haven 1, what are you looking for from, you know, NASA or the government to help you, you know, continue to develop this platform while also, you know, keeping the demand for the market going?
Yeah, thanks for the question, Robbie. So I'd start by saying sort of the current track we're on, working with NASA through the CCSC2 program is exactly what we need, right? That provides us the aperture to have some of those learnings that Lee's alluding to on what are some, you know, good ways to do what we're embarking on. How can we sort of begin that technical collaboration with NASA now? Ask them for those resource requests that, you know, provide us with some insight on all the lessons that have been gained over the past 2 decades of the ISS. So we're actively engaged in that effort right now, and we're appreciative of NASA's efforts to support us in that. It's providing us what we need, and I hope in turn providing NASA a picture of what we're capable of and how we're sort of planning to undertake our missions. And beyond that, you know, our vision for our company, I'd say, is aligned with the country's vision for the CLD program and maintaining a continuous presence of humans in low Earth orbit. We do have big aspirations to develop, you know, larger stations beyond Haven 1 that will be sort of, you know, presenting in the sort of fashion of round 2 for CLD. And part of those visions are with an aim towards deep space exploration, right? Finding new solutions to mitigate the effects of, you know, detrimental effects of human spaceflight on the human body. So one thing I didn't mention in my intro, but I most certainly need to mention, is part of our vision involves developing artificial gravity capabilities by spinning, right? And so we think that's a compelling capability that we're going to step into incrementally. We're going to do in a very sort of deliberate way, you know, ground test, incremental sort of test on orbit without crew, and only if the circumstances are right. And we think that we've done all sort of those incremental steps that we think are contributing to, you know, a good test outcome would we entertain sort of doing that for the crew who are visiting Haven 1. But even that capability with Haven 1, we expect to get up to, you know, 1.6G, sort of simulated lunar gravity out of the spin test that we plan to do on Haven 1. And we'll see where the compelling sort of, you know, payload opportunities are for us there, given the payload accommodations that we'll have on the vehicle. So that's all to say, you know, we are trying to operate in step with the direction of U.S. policy and NASA's goals for low Earth orbit as well.
All right. That's very exciting. You know, having a space station spin up to 1.6G might be some sight. Olivia, you know, as you're essentially a commercial company already operating in LEO, right? So as you look forward to the future and you see all these possible CLDs out there where there might be many of them, you know, what are you doing to prepare for that future state where all of a sudden you could have a lot of demand at your doorstep wanting to do biotech research in space?
Definitely was thinking about it the opposite way, where there would be a gap and I couldn't do business.
We'll get to that later.
But before I, you know, get into that, I just wanted to echo Lee. I really appreciate, you know, So we're a commercial company, and it's interesting because Rhodium and VAST are probably two of the commercial companies operating without NASA funding right now, and we're successful. And so it's kind of pointed that we're on this panel, because we're kind of leading the way currently, living in the CLD lifestyle currently right now. Not that we don't want the NASA funding, but but we've been successful without it to date. And with that said, some other folks in the room, NASA and ISSNL, might cringe when I say this, but it has been really rewarding to work with NASA. We've found a way to get our payload from conception to the space station within 6 months. So the processes that NASA has, they're not all broken and they're not antiquated. We found as a company, a small company, we're nimble, but we work at the speed of business. There are processes already in place that aren't broken, that should be utilized. Yes, modified, but looking into the CLDs, and everyone is so eager to change everything, that kind of gives me pause for, it's working right now for my company, and we are successful right now, and I'm a little terrified to think that there might be a whole new process whenever the transition happens, because the CLD is wanting to be so drastically different from NASA. I just say, it's good to work together and to use what's not broken.
Yeah, I'll echo and add on to that too. Some specifics for our program, right? And let's keep the artificial gravity spin test aside. We're trying to keep it simple, right? And that's sort of old adage, keep it simple, stupid. Our engineers take to heart. That's what's going to allow us to sort of execute on the timeline that we have, at least for Haven 1. Existing standards, like docking interfaces, IDSS, right? Like, we're not deviating from that. We know it works. And, payload accommodation,
Yeah.
right? So 57,000, right? Like,
It's working.
it works. Our customers that we're hearing from, they want to know what their interfaces are going to look like. We've got, the power, thermal, mechanical, data all scoped out. Slot you in. We're going to have good up and down mass, and you're going to be familiar with how to operate on our station if you're flying a payload. So we're taking sort of all the existing work and saying, what's the easiest way to deliver on the capability that we want to have without reinventing the wheel, without getting too creative on what we're trying to fly, so that we can sort of take a step forward in the direction of true commercialization.
Agreed. So with the customers knocking on our door and how we're going to handle that part, it's important to build partnerships like at symposiums like this. It's important to build collaborations between different companies who can handle certain workloads, who are good at what they do. For example, VAST in a vehicle, that's what they do. Rhodium does biotech, that's what we do. Another company, Aegis, is here. They do external, that's what they do. And, it's good to partner and have those collaborations because one company can't do it all. And so I'm looking right now to see who is sustainable, who is serious, who is not flashy and markety, because we need work to be done right now. We'd only have 10 years or so, but that's pretty quick considering that we've been operating successfully in space for over 20.
So I think it's a great point, Olivia. Lee, I want to talk a little bit about the current state of affairs of the CLD program. You've had a long history of working with these sort of private-public partnerships with NASA and the Commercial Space Office, and seen a lot of these programs come to fruition. What can you learn from the historical perspective, of working with all these previous programs? What can you tell us about the current state of the CLD program with the different entrants, kind of joining up together, or new entrants coming online like VAST and other folks?
Well, I think one important thing to remember, if it seems like some kind of new environment out there, is that we've seen this before. When we were doing the commercial cargo, and also the commercial crew program, we had a stage where there were a lot of entrants, a lot of participants. They're in different stages of their maturity, so it's not really unusual. What we've seen in the past is that the competition is critically important for these companies to be able to mature quickly and to be cost effective. There's some fallout. There's some companies that don't survive the process getting all the way to deploying their product. but I mean, that's a healthy process too. It has to occur. I can say that when we are trying to be an incubator, that we don't see all these participants as a bad thing. We're excited that we have some unfunded SpaceX agreements with like the one with VAST. They're actually going to fly hardware. You know, typically unfunded SpaceX agreement means you might run a test and share the data. And so this is dramatically different, and that's fantastic. What we need to do to take advantage of this environment is to be nimble and be prepared to take action. And the example I like to use is when Kistler Space kind of fell through and was unable to succeed in bringing their product to market, that we moved fairly swiftly. We terminated their funded SpaceX agreement. We recouped the money that was being used for that, and we recompeted it immediately, relatively, as the government, immediately, 6 months. And we're able to place a new funded SpaceX agreement with well, it's now Northrop Grumman, and that was a highly successful one, right? They came out with Cygnus, and it's been awesome. We need to have the ability to respond to what the market is doing, which can be difficult. It can be difficult for the government. We have to sort of keep our eye on how things are going and be prepared with plans on the shelf. I think that's my best answer.
All right, yeah, nimble. I like that. Very nimble. You know, Brad, Olivia just brought it up. You know, I think from her perspective, a gap is very disconcerting. You know, what are you guys facing right now as far as challenges to avoiding this? Are you facing any challenges to getting Haven 1 off the ground, you know, to prevent this gap? You know, how are things going? You know, are there any technical hurdles you guys are still trying to overcome? You know, is there anything that NASA or we can do to help, you know, support your efforts?
Yeah, I appreciate that, Robbie. So right now, I'm happy to say sort of schedule's looking good, right? We've got a really good relationship with our launch provider, SpaceX, and sort of working in step to meet that sort of late 2025 schedule that we've got. If there's any, you know, I mentioned sort of the spin test, but just thinking through core capabilities, core technologies that if you're going to be flying a space station, you better get right. We're giving a lot of attention to ECLSS, right? We want to make sure that the way that Dragon and our station are going to be interfacing and sort of having some shared systems and sort of some dependencies between our systems is going to work out exactly how we want, right? So we're giving proper and due attention to that. And I'd sort of characterize that more in the vein of anybody proposing to operate a space station. You know, that's going to be sort of a core area of your IP, of your capability to get ECLSS right. A lot of the other capabilities are flying, whether it's RF, whether it's propulsion, and the like. You know, those capabilities are known. We've got sort of vendors, you know, partners that we're working with that have high heritage on a lot of the subcomponents we'll be flying. And we're going through each of our sort of design decisions, sort of fresh with what is the best engineering decision, make versus buy in each case. And so that's overall, I'd characterize, you know, schedule's looking good, giving good attention to ECLSS, and, you know, we'll keep you posted.
Yeah, you know, making a human-tended spacecraft is definitely much more complex than a robotically operated one. So Brad, I'm gonna ask you to put on some earmuffs. You know, Olivia, you know, you mentioned it earlier, but you know, how concerned are you about a gap? You know, is it a realistic thing? You know, and what would that do to your business if there was a gap?
Yeah, there might be. We don't, I hope not.
No, we got you.
Okay. But right now, I'm not going to wait to find out. So what we're busy doing is, you know, like I said, we're a biotech company, and we're a biotech company operating in space to exploit it for its capabilities on biological systems. What that means is to bring home novel products. We're focusing in building programs in bioprospecting, which is basically what they did when they went to the Amazon rainforest to find new animals and new compounds and new chemicals. We're doing the same thing, but utilizing the cosmos. We're seeing some similar reactions. And that program, to me, is very important because, you know, our chief science officer in the room, Dr. Heath Mills, bug him about this question. But most of the pharmaceuticals on the market have come from novel compounds found in natural products. And so what we're seeing when we, diversify and utilize the cosmos as the new Amazon rainforest, we're also building that portfolio that drug companies will be excited and knocking at the door to get a hold of those results to see what was developed. So diversification of our portfolio right now to be a Earth-based company, a biotech company, but just exploiting the environment of space for business is what we're looking at. So we also have other diverse business lines of efforts. We help different payload providers develop their launch pad facilities for the laboratories, payload processing facilities. It's important to make sure that cross-contamination between the engineering and the science doesn't happen. But there's a lot of spaceports being built. There's a lot of companies and countries entering the market. So having that scientific perspective of payload processing is another, revenue stream that we excel at. So I'm not going to wait, but we'll be ready in case it does.
Diversification is key, is what you're saying.
Yes.
So, be interesting to see, the folks that rely a little bit more on the space environment, how they're preparing for this, and hopefully today I can have some discussions with some of those folks later on. Lee, I think NASA's, like the rest of us, are very concerned about a gap as well. And you mentioned being nimble earlier on the CLD front, but what about on the other side? And, if they're not ready, is NASA developing a response to, to kind of be there to fill that gap? Or, what kind of approach are you guys taking?
Well, I have been accused of being excessively practical, but if you look at the gap, there's really physically only two things you can do. You can either extend ISS to last longer, or you can fly your CLDs earlier. This is the way, right? Mm-hmm. So I won't talk too much about ISS because I'm not the right person to talk about that. I know that they're always going. This is NASA. We're always working on a backup plan. So there is a plan to keep ISS flying. I have absolute certainty. I don't know what it is, but I have no doubt there is a plan. If it becomes necessary to extend the date. So that's kind of this part. If you want to do this part, we've found in the past that this is not the kind of problem where you can just bring more money and the schedule gets resolved. Our experience with providers for other capabilities has been kind of they're going to get there when they get there, and money is sometimes not the issue. They just need to get through their process. But one thing we could think about is a human-tended capability or an evolutionary approach, some method by which we get something up there and kind of declare a partial success and start performing some activities. And that's the best I can think of.
Like the free flyers or.
Yeah, it's an interesting point. Thinking kind of outside the box there. Well, stepping stone, if you will, just to make sure we maintain some capabilities. The ISS, when it was created, it took many, many years to get it up to full speed. And today, we're operating 200 investigations every year, launching multiple spacecraft. There's so much activity going on. Kind of makes you wonder how long it's going to take before the CLDs are at that capability level. So Brad, what is your guys' timeline looking like to kind of match or exceed what we can do today on ISS?
Yeah, so let me sort of give shape to kind of the volume we're working with, right? Mm-hmm. So we're going to be sending Haven 1 up, basically maxing out the Falcon 9 fairing envelope, right? So ballpark 10 meter by 4 meter, right? That gives us a lot of space to work with, nowhere near the ISS, of course. But we're proceeding with sort of the accommodations and specifically the payload accommodations as well, apart from crew accommodations, in a way that is informed from sort of conversations we're having with our prospective customers. We know we're not going to be bringing everything in the kitchen sink on our first go, so we're trying to hear from our customers what is that sort of perfect solution right now for what we can offer with the rack space that we have and the amount of slots that we're going to have for those payloads. Do we need to add a freezer, an incubator? maybe some other sort of equipment. We don't need everything just yet, and we know that, and we're not going for that. But we're trying to do an initial capability demonstration that provides good value for the payload accommodations that we'll have, for the science that we want to fly and that our customers want to fly. And that's where we're going to start. And then beyond Haven 1, we'll expand from there.
And Lee, you made me think of something else that I should mention. In terms of diversification, it's not, there are other players out there that if you're not in the room talking and you don't know that they're there. So there are some units that are meant as fuel depot stations in space. The Defense Innovation Unit has funded a few. And having a partnership with some of those, they're looking at, well, we were going to just do fuel, but how do we accommodate science? They're also looking at that. So just having that cross-pollination between industries has been helpful in hoping to bridge the gap.
Yeah. Well, getting back to what Brad just said, I think Olivia would love it if you had a freezer and incubator on Haven 1. Life science has been a big part of the portfolio, and those are some key capabilities that are needed moving forward to keep that kind of industry going. I want to throw a bonus question in here. I'm surprised you guys. But I think it's a fun one. Olivia, what excites you the most about this new paradigm where we could be entering, in this commercial era where it's a thriving economy, not just from a business perspective, but a personal one?
Well, I'm a lot like Lee in that perspective. I'm very practical. Mm-hmm. So, I like it when things happen. That excites me. Mm-hmm. And, what has been exciting is just, in 2019, we signed our agreements with ISS National Lab. Mm-hmm. And just to see how far a company like Rhodium, a very small company, less than 10 people, the things we've been able to accomplish, I know that there's more out there. There's more companies like mine. There's more opportunities like mine. In the next few years, I think we're going to see 5 Rhodiums, and that's exciting.
All right. Brad, what about you?
Yeah, I'll share. So starting with a personal note, I think, I probably caught the space bug for myself back in 2010 and have had the good fortune to land exactly where I want to be with VAST and having a lot of fun in the role that I have with the company. But what that speaks to is really sort of as a company, we're excited to be able to contribute to that vision that our country has, that the international community has, towards long duration future deep space missions, right? So with our artificial gravity capability, that's not just because we think it'd be fun, that's because we know everybody wants to go to the moon and then maybe beyond, maybe Mars, right? So what are things that we can do to have some test beds in LEO that we don't currently have to provide those gravity environments that might be useful before a full duration mission to the moon. So that's what excites me, why I'm here at this symposium, Beyond Earth, right? I'm very much sort of a subscriber to that vision as well.
Yeah. Lee, what about you besides the obvious of looking forward to retirement?
Well, hopefully I will be able to keep working long enough to see some of these concepts fly. It's always want to see how it turns out. So I'm looking forward to that part. I will say that the thing that's excited me over the course of my career, and I've been so lucky that I've been kind of a space nut without a technical background, and yet I've had the coolest job that there is, as far as I'm concerned. Even the brief moment of time when I was working with Courtney's dad, that was still the coolest job. But I would say what really excites me about this job is I do all this. My background is in procurement, and I've run these competitions, and then I got into these commercial competitions, and just to see the proposals, just to see what this industry can do, it just blows me away. That gets me up in the morning to just see what have they done now. That's kind of what excites me.
All right. I tell you, for me, I'm really looking forward to that needle in the haystack, that we can finally find that one thing or two things or maybe a handful of things that we can manufacture in space and bring those back home and help develop this economy further and make it a thriving industry, a space industry, and everybody that grows up wants to go work in the industry versus the handful of us that make it up here. So I think we have a few minutes left over if we want to take some questions from the audience. We got one over here. All right, we got a microphone. Oh, right here. Who's first?
This is for Mr. Powell. Vast be nimble, vast be quick, vast ensure no CLD gap exists. But
Amen to that.
no, this is. I just want to say this is very informative. I knew very little about this going in to all these different things you've talked about, and it was just great. So I had a little creativity while I was listening.
Appreciate it. We'll run that by our marketing team.
A
See if we can get
well-rounded
it online.
audience. We have poets among us.
Hi, am I on? Yeah, Bros from Space Force here. Good morning. Since this is such a forward-leaning and mixed commercial and government audience, I'll throw a thought out for consideration that I would love to hear the panel thoughts on in response to one of the last things you said, where you said, we want to try and find things we can make in space to bring back to the Earth. And I thought, well, that is awesome, and I'm sure there will be a lot of things as productive capacity goes out there. But some of us are thinking that maybe the value of manufacturing in space is also manufacturing things in space for space. So if I say to myself, what's my difference, for example, in cost of manufacture on orbit or cislunar versus the cost of manufacture terrestrially plus launch, right? Are there structures that are awkward to launch? Are there materials that are awkward to make? What is the economy of making things in space for a cislunar economy, as opposed to a cislunar means of production, which is then focused back on terrestrial, right? So, I would be very interested if the panel or others have thoughts on that. Over.
Yeah, good question. That's one other thing that excites me, talking to a terrestrial-based company who realizes they can also utilize space to improve their technology for Earth. But there are those, that category, it's smaller, for space manufacturing in space. Yes, there are limitations on toxicity levels, biosafety levels, coming from a biological perspective. There are limits to what you can launch. There is space requirements to what you can launch and mass requirements to what you can launch. So it's, in my opinion, and I think until we master the art of manufacturing in space for Earth-based products, because we have such a robust manufacturing economy on Earth, we master that before moving probably to the next step, because we have articles of reverse engineering. So when we experience a change in space for manufacturing that benefits a manufacturing process, we can preserve it in space, bring it down, and identify where in that sequence did it change, where was the improvement. And to me, that's minimize launch costs, minimize time and effort, expertise level, and master that, and then say, okay, well, this could also be used in the space environment. Now that we have the key, how it operates in space, let's put it in a space environment to make the 2.0 version of that product.
So I will tell you, I think my response was probably a little biased, because at the National Lab, we're focused on the Earth benefit. But as you stated, in space manufacturing for use in space is going to be very vitally important, especially for this community moving out into cislunar, right?
Correct. Correct, because right now, if you look at some of the biomanufacturing missions that we've done, even the one that we're doing currently with DARPA, looking at the process of biomanufacturing and is it possible in space, we're producing novel compounds such as vitamins or therapeutics that could be used in a space environment, or biodegradable plastics that could be used in a space environment. That plastic or that development doesn't have to necessarily come back from Earth. It could be used for in-space application. And I think it could be fully intended to do so, because we're also getting the data sets on lunar and Martian gravities. Rhodium has a centrifuge that we're utilizing on ISS for the true lunar and Martian gravities for those biomanufactured products. So there is an application, and there is a need, because we're not going to be able to create space-based therapeutics. Our bodies won't even look the same when we're living and operating in space. We'll be totally different. We will be the aliens. But yeah, that's a valid point.
Yeah, and I'll add, just in the context of Haven 1, we're already hearing from customers an interest in sort of those capabilities to do manufacturing experiments and the payload accommodations that we're scoping. The direction of that activity, whether back to Earth or further in space, I think is open-ended right now. My colleague Tristan here might have more insight for you on that if you want to catch him later.
Last question. All right, from Pete.
So it strikes me that some of you are suppliers and some of you are customers. How useful would it be to have a government-wide aggregated working capital fund that would allow NASA, NSF, National Institute of Health, Space Force, Air Force Research Lab to pay into some common working capital fund that then could be funding any number of research on sort of a common vehicle?
Yeah,
Preferred.
I would tell you from my knothole as the the current national lab, and we're helping shape some thoughts on what a future national lab might look like in the CLD environment. One of the things we've been poking on is that exact thing. Having a collective fund by all government, so that all government can access the future CLD environment and perform research in space to suit their needs. Whether that's the NSF, the FDA, Department of Agriculture, you name it, right? They're all interested. We recently just had a workshop where we touched on this very topic. Right now, they're all scared of the full freight, costs. NASA's been subsidizing a lot of it for them. And we're just starting to pique their interests, some of these non-traditional space government agencies. And so it's a slow stepping stone to get there, but hopefully one day we'll get there if we can build enough momentum to get all of government focused on doing research in space for the betterment of life on Earth or for future exploration purposes, as finding us a new home.
It would certainly be more time efficient. Right now, we spend time working with each agency one-on-one and going to their offices and developing why space. Why is it important? Why should you care? What products can you get? How can you exploit, in a good way? And that's time consuming for a small business, but it's effective if it's done correctly. So having a consortium or a collaboration where everyone kind of comes to one spot and we give one pitch to 200 people instead of 200 pitches to 200 people, that would be very preferred.
Yeah, and I'll add one more bit. If you have a collective fund, I think that opens up more opportunities to purchase more resources for each individual agency, via economies of scale. So that's really something to look forward to. All right, and with that, I think that concludes our panel. Oh, Courtney, all right.
Gonna be pushing if this is on.
Don't tell Steve.
Don't tell Steve. Is this on? Can it be put on? Or I'll just yell out. Okay, that's all right, great, thank you. And I apologize for pushing a couple of minutes longer than we anticipated. Great panel, great discussion. One comment and then a question. To Lee, I had a surge of adrenaline when the word retirement was used, so I hope I'm in denial. I'm hoping you really can't quantify the amount of corporate memory and Lee's incredible contributions to commercial space partnership and NASA. You just can't. So I'm hoping there's some mentoring going on so that when decades to come you consider retirement, that there's a succession. The other question really has to do with safety. Lee works in a world where you talk about being excessively pragmatic. There are all sorts of overseers in the political system, Congress, et cetera, that are second guessers, And he and I have been around long enough to remember when Apollo 8 could demonstrate its engine on the back end of the moon. Try that today. But you're commercial. So Brad, let me turn to you. In the safety world, if you look at, I don't know, Lee, if it's 508, the regulatory documentation associated with proximity ops, you can fill this room with it. You have, obviously safety is preeminent, but you have to approach it somewhat differently. It can't be a straitjacket, So I'm just curious from a cultural mindset standpoint, how do you approach safety from the world of the government.
Yeah, I'll try and be
Yeah.
brief, recognizing the time here, but it's paramount to us, right? It's central to our ability to accomplish what we're intended to accomplish, to set sort of that interim capability for future CLDs to come, hopefully ours as well. We're treating it super seriously, right? So we're building out our flight safety and mission assurance function. I alluded to the standards that we're taking to heart and learning from and thinking what is the best way for us to proceed with the Haven 1 mission. And then ultimately, we're not going to fly any crew unless we're good to go, SpaceX is good to go, our crew, our customers are good to go, and we have that high degree of confidence that we're ready to step into that operation, right? We're going to be flying Haven 1 for a period of months before any crew show up. We're going to be able to do a lot of checkouts, make sure all lights are green, make sure the sort of balance of the systems that we need are exactly where they need to be before we even step into crewed operations. And we're going to be flying with a partner in our launch provider, SpaceX, who's well versed in these capabilities as well, and is going to be looking over our shoulder throughout the OAS too.
All right. Well, thank you, everyone.